So let's continue our discussion of names, bindings, and scopes. So scope is basically the area, the textual region, right, in your program where you can actually use this, where the binding actually works. That's what binding is active, right? So this is binding maybe maximal size where you cannot change it, basically, right? So there are two ways of determining this binding, right? The scope of the binding, right? Whether it's statically, again, or dynamically, right? So also there are different rules. When can you use things like scope? For example, right? In Java example here, I give Java example, local variables, well, it's like most languages, you cannot use a local variable before it's declared, right? You can't. But some things you can. Well, let's give an example, of course, in Python. So, scope in programming languages, right? So there are four types of scopes in Python. Let's see. Local scope, right? Meaning, we'll look at examples in a moment. Local scope means something that's local to the function, right? You cannot use outside. And of course, those are the best type of scopes. Again, as far as coming from functional programming languages, of course, it's very clear, right? There's very little question, right? If everything's inside little functions and it's only within those functions where the variable, the naming exists, right? It's great, right? So it also, by the way, for example, there's also some functions. You can think of it. Many languages let you have functions within function definitions, right? Meaning scoping also for function names, right? You have function defined inside the function, right? It's not available outside that name. It's not bound outside, right? So local scope, global scope, I believe, right? We'll have global scope, right? Enclosing scope, right? Names defined in enclosing, right? Scope, right? Right, this is called closure. We'll talk about the closures. This is a kind of tricky one. Global scope, very well known, right? Built-in scope, right? So LEGB, right? So Python follows, right, yeah. So Python follows the so-called LEGB for scope resolution, right? So local first, local enclosing, global built-in, right? So local first, then, yeah, finally built-in scope. Right? So that's, of course, meaning whatever you do locally has precedence. Of course, and again, this is Python, LEGB, right? But other language maybe has some different ideas, right? But again, the idea, what's almost always, the tricky part is where local seems kind of makes sense, right? Local stuff is most important, right? But the tricky part will be the second part. You should probably have not really dealt much the enclosing part, right? The global part is fine. It's that global variables, they are bad. Use them sparingly. I mean, sometimes you need to, right? And of course, built-in scope also makes sense, right? Things are built in and it's available, right? So, but enclosing scope examples will be kind of a little bit tricky. So let's look at examples of these, right? Let's take a look, right? So code, local scope example, right? My function version 3, right? Local Valdis, right? Call my function, right? Of course, right? So, and of course, as we know here, local name is not available outside this function, which is of course perfectly fine, right? So, local name is bound within this function, right? Now the question is, now of course, now the question is, right, where is local bound? Where is it bound, right? Again, language depends, of course, where it is, but of course, generally it would be within the function stack, right? The function stack frame, right? So that's more technical detail, right? But functions get their own sort of like little stacks, right, where they have their, they store the data basically, right? Within that, when you call this function, okay, you get your allocation basically, right? The stack frame, right? When we dealt with C++, there's the other type of memory, right? There's stack, right? What other one? What's the other type of memory we use when we allocate memory? Heap, yes, codes it, right? Yeah, we have heap type of memory, which is sort of like a global, globally allocated, basically, right? Just a big chunk of memory, right? So of course, with Python, you don't really have to, you don't have to worry whether it's actually where it lives, right? You think it's stack, or maybe there's underneath some heap, maybe there's some optimization. You don't really, it's sort of a little bit like a black box, less because again, you're living sort of your abstraction is really high up, right? You're up and high in the mountain, right? So, all right. So we have, so now we get to the fancy part, local scope, right? Example, right? So let me do this local scope. Local scope, right? Yeah, okay. Now, now we want this. This is when, well, we still have some. We still not completed. So enclosing scope. Enclosing scope. Lexical. Enclosing. Right. This is the trickiest one. Right. Let me see this one. Come on, Markdown. Okay, so enclosing scope. Yeah. Right. So this is the thing is like the weird part. I'll show you the weird part here, right? So let me show you this weird part. So let's do this. So we'll define outer function. Let's define outer function. Outer function. I'll call it outer. Define outer. Outer function. Right. And right. Let me see. Well, not like this. Right. Outer name. Right. That's not it. Right. Right. Outer name. Right. But this, of course, is not the big part. So now I'll define inner function. Right. Right. So this is a weird part, right? So, right, you can of course call it here, right? Right. On function. All right. So you're not going to be surprised what's going to happen if I do it for now. For now, we will just define this. So let's see what's happened. Nothing happens, right? Because why? We just bound into our global namespace the outer function. Not, calling it, note, we did not bind, yeah, right? So, okay, so far nothing too scary, right? This is not too difficult, right? I mean, you might say, okay, why would you want to do this? But the thing is, okay, Python is maybe not the one where you see this most. In JavaScript, this is often used a lot actually, right? So let's see, this also comes from sort of like a Lisp world actually, right? So now let's call it, right? Again, let's call outer function and see what happens, right? Right, so we call outer function, right? It will reference inner, the outer function will call the inner function. So let's take a look, right? No error, right? But if you think about it, right, it's like if you first time you see this, you think, okay, if you don't know anything about scoping, right, you just know your basic programming, it's kind of weird that actually you are calling inner function, right? The outer function is calling it, but in this moment, right, the outer name is available. So this is the weird part. So this is a slightly tricky part, right? Inner function can access outer function variables, right? This is again, JavaScript is a big one, which use this type of approach, right? And Python also, right? So we'll see where the weird part comes. Basically, okay, because what happens now is, let's make a closure, right? Actually, close over it, basically. Let's make a counter with this, right? Let's make a counter with this, right? Code. Let's make, yeah, on its call. Let's make a function in terms of function, right? we'll keep some state, right? So define function factory, right? State, right? So, right. So let me see the inner function, right? Let me see if I actually do this right. So we are returning the state, right? Right. I wonder, do you need a non-local, right? So let's take a look, because what you think about it, right? The state is not available, right, outside. So that's a kind of, I thought you didn't need this word, by the way, right? I thought you had but I guess you have non-local. It's not local to the state, right? So state, because it's already in there. So let's think about this. Is this actually what you need? Right, so make and also function factory on custom header, right? And maybe let's say something custom adds what value, right? And let's do this add value, right? Right. So basically, this we can make it custom. So now we will have a custom increment, basically. Okay, let's take a look at this, right? I'll call this custom adder factory, right? My adder, right? So adder, right? And I would say, right, let's see, do we need this adder? Custom adder, right? Really weird example, I know, but this is actually, like I said, not so much in a Python, but C, right? So this is a closure, basically, famous closure. People used to write blog posts about this thing. I don't know, there's tons of them about this, right? So let's make two custom adders, right? So add 5 and add, let's say, I don't know, 10. Okay, why not? I guess okay. So we have add 5 and then 10. All right. Now it returns a value, right? And let's print them, right? So let's see, did everything work? Everything worked, right? Right, so let's run. Let's print, let's call them a few times. Print add 5. It should be 5, right? Let's take a look. State is 0, right? And let's take a look about this now. Print, this should be 10, right? And this should be, let's do one more time. Let's see if this works. Indeed, it works. Okay, so the only thing is what's kind of weird is that this actually had to be non-local, right? So the state, right? So state closes over. So basically, custom adder, right, doesn't have this version of state anymore, right? However, right? We could also start state, maybe, right? We could modify the step start state to 0, right? And we keep, so each function. So now the question is, of course, the big question is now, let's call add 5, right? The big question is whether add 10. Now the big question is what kind of state will add 10 have? Let's try, let's see. Print add 10. It should be, right? This is the way closures work if they're properly implemented. Let's see if this works. And indeed it works. So by generating basically, so the state, right? So we're returning for each. So we close over. So basically we close over the state variable, basically, right? So kind of tricky. And again, I don't use it much myself in Python code. I mean, it's possible, right? This concept, right? Unless you're writing a blog post about this, but but if you're writing a lot of JavaScript, if you're going to work on front-end projects, right? This comes up from time to time. This is the reason this was actually, so there's some historical reasons why this is sometimes very important, because we don't have good scoping rules. Like JavaScript was infamous for really bad scoping, right? So people use these closures to sort of get sort of decent scoping, basically. They made their own scopers, basically, right? So practical use of this, right? So let me write this practical practical use of closures, right? So closures were widely used in JavaScript, right? Yeah. So advanced programming techniques, right? Yeah. Right. Right. So basically, uh, closures were used in JavaScript because the scoping was in early JavaScript was very limited. Right. So not something you see every day, but again, like so kind of like so the only thing is why do you need also I would have in JavaScript you'll need this no local variable. Okay, but so hopefully you can sort of make sense. Bless you.
Thank you.
All right. Now, so we got our static. So we have our closures, right? On LEGB. So okay, well, okay, let's do globals, right? So let's do globals, right? We have our outer functions, right? Local and closing scope, right? Let's do some globals now. Those are easy, of course, right? Globals. Let me move this up. Why can I do this? Can I move this up? Escape X, escape V. Yeah, all right. Now let's do one more. Closures. So closures. Now let's look at global scoping. Let me see if my names are correct. Outline. Names, binding, static, there's dynamic, scope, local, lexical, critical closures, global scope. All right. The global scope is exactly this. Global scope. Yeah. Right. Oh, yeah. Yeah. So variables declared from any function in the module, right? We already saw some usage of global scope, right? Right. Okay, right. All right. So let's look at the example. Right. Easy global variable example. We are my global val this, right? All right. Why not? We already saw this. Right. Come on. Define a function, and of course we call, right? So again, local, and we call it, right? Of course, yeah. And this is really simple stuff, right? Again, global. And you know, sometimes they, sometimes, often some global state is global state. Yeah, so that's the thing, right? So some tricks, if you need global state, you could have this big sort of global blob object, maybe, right? Maybe you have this global sort of like a mega object with some ideas. So we looked at the L local enclosing the closures, G global, and M was modules, the module scope. Or built-in scope, right? So let's look at built-in scope, right? So finally, the built-in scope, of course, will be just basically the values we already know. Right, this is all easy. And finally, global built-in scope, right? Yeah, yeah. So let's look at the example. This again, built-in scope example would be, yeah. So print, yeah, print. So yeah, also like max, oh, right, also so print max, yeah, right, of course, right. So again, nothing too hard, right? So, of course, we have also things we didn't really talk about is the class, an instance scope, right? We have also, since we have time, right? Let's talk this to death, basically. Let's talk this to death, scope rules, right? Right. Let's talk also class versus versus instance scope, right? In OOP, object, yeah, right? So class have their own scope, and instance class have their own scope, right? So this means that, of course, let's take a look at some of these examples, right? So class scope means class scope, yeah, yeah. You have a name inside the class, right? An instance scope is scope of name inside the instance of class, right? Let's look at some examples, right? Let's look at some examples of that, right? So, so let's look at example of class scope in Python. Class my class, right? Right, so class attribute, right? On class method, of course, right? Class method. So who remembers? So, right, class method, I am class method. Print, I am a class method. Same static method. This means I am same. Right, so this is the part. So this kind of tricky part here. So CLS note, we are using instead of self, right? So this, have you seen this is a class method decorator? Anyone use this ever in classes?
I think so.
Maybe somewhere, right? So again, a little bit tricky, but not too tricky, right? So again, so why would you want to do this? Well, again, let's say you're making a class which will hold a bunch of calculator functions, right? So the usage would be of this, of course, when you don't need to have each instance does not need to have a separate function, right? It's like sort of general methods, right? They don't have anything unique, right? So you would use this, we would use this, right? So class, right? So we usage of class scope. We would use class scoped, yeah, variable and functions and method and methods, function, class functions, right? All right, you're gonna, oh, you're leaving early, right?
Yeah.
All right, it'll be like 15 more minutes for the rest of you guys. You can survive, right? All right. Still awake? More or less? All right. You guys kind of follow this, right? More or less, or like more or less, right? Yeah. If it's something like completely unclear, let me know. Because if I was in your space, I probably would be, thinking, okay, can I follow this? Falling asleep a little bit. No, but no, you're all awake, right? Hopefully, so that's good. All right, so usage, when we use this class scope, right? So usage would be, this would be useful if, yeah, if we have class common data, yeah, obviously. So another usually these type of methods, yeah, right. Note they one important, yeah, we can call these yeah, before creating an instance of class. So that's a very interesting point here, right? We can call it before we define any instances, right? So let's try this, right? So let's try this. So we can call it even before, right? So let's do this, right? This will print my class. Get class name. Let's take a look. Yeah. All right. Of course, right? Of course. Let's create two instances. Yeah. So yeah, okay. Now let's look at this class value. Um, Class value. So this is class value, right? It would be like 42, right? Right. Let's try this one more time. Uh, let's modify class value, right? Let's see. This is kind of tricky, right? Right. Print. So it's a class value. Is this actually really gonna be? Is this actually gonna? I think this is not gonna be. If this was a list, it would be the same. But I don't think this actually is gonna work like we want it to work. Let's take a look actually, right? It's gonna be 41, or let's take a look, right? Yeah, 43, right? We do it again. It's 43 still. Okay, right? And now let's call it. And now let's call. Yeah. Yeah, I think it's still gonna be 43. I think, right? It's gonna instantiate. Let's take a look. Yeah, no, it's 44. Okay. But right. But will it be 43? I'm curious. I don't think so. No, yeah, 45. 45. Very interesting. Actually, very interesting. Yeah, it is shared. So, yeah. So it is shared. Very good. Let's take a look. Yeah. 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 So that's it. So this looks like my theory is. Right. Yeah, okay, let's take a look. So it should be 47, no, 49 already, right? So they all share, right? Sharing is caring, right? So they all share the same data, basically, right? Again, depends, right? Oftentimes, before you create instance for a particular reason, you don't want to share, right? You want your own data, right? So to reiterate, so to conclude, right? So as we saw, so included on class scope values. So we saw that we can force, yeah, right. So sharing is caring, right? All right. Of course, you can do locally. I mean, locally, of course, the default, right? So we have, I guess we have like 10 minutes. We're almost finished. So let's do one more. So locally, instance scope variables. Scope. Yeah. The standard. Yeah, yeah. Right, we all know that, right? We all use init, right? You all guys know how to use it, right? So let's do that, right? Let's do that, which is just standard. This is more. This is the usual, right? So make my 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 boarding. Let's make a normal class, right? 42, right? And we can do also mod mutate, right? Right. So init, right? And of course, as we all know, name, right? And of course, we see some normal values, normal A, B, right? Yeah. So, right? And this will print too, right? So here you can see that, and although there's no such thing as class here, right? There's no class data because it is not shared by the different. Okay. So that of course is the instant scope. This is which we use all the time, right? So LEGB. So now the lifetime of variables, right? Yeah, I touched on this already a little bit. Garbage collection, right? Oh, there we go. Lifetime of binding variable, right? Right. So, yeah. Right. So this is. We could check our memory usage, of course, and we could see that is actually. Let's take a look. Let's see. What was memory? Let's see if you can do free memory, right? You can do free. Let's allocate some memory, right? Let's do this. Let's make a code. Let's show free memory in Python. I think it is GC. No. Show how much memory we have available. Import PS util. I think it was PS utilities. Yeah, I think so. Let's take a look. This work? Oh yeah. So I have 4 gigs, right? 4 gigs free available. That's about roughly this one here, right? This value here, right? All right. So let's do some. Let's allocate some memory. Let's create a big list of numbers. I think let's make 100 million, right? So big list 100 million, right? So this should take about 800, 900. Right, so let's take a look. How much? Let's take a look. Well, okay. So why so much, by the way? Let's maybe even worse. Let's think about 100 million. How much does each integer take? 64 bits, right? So 8 bytes, right? So that would be okay. Actually, I have a feeling that this is going to be worse than that. Actually, let's take a look. All right, you see? Oh my God, kernel crashed. Okay, why? This was worse. The kernel died. Let's restart. So why did it crash? Because I was maybe, so this would be not, so 10 million. This would take about 80 megabytes of memory in C++ or Java. In Python, it would take much more. Yeah. All right. Let's take a look again. So, import. Restart kernel. Let's start. I killed the kernel. 4.5 gigs. Let's do this. All right. Yeah. So 400. Right. We used about 4 or 5 times. Yeah. Right. Yeah. Right. Basic. Instead, the specific libraries such as NumPy. Yeah. Underneath. All right. So yeah. So now, of course, I allocated more memory. What is going to happen if I do this again? Right. So okay, but now let me make so the big 10 million list will be garbage collected because right. So my big list, right? Not really a big list anymore, right? So let's take a look. But a good question now. Is it going to be instant? I don't think so. We'll see. No, it's instant. In this case, garbage is completely instant. So note, depending on Python. Yeah, the memory, but in this case, it was immediate. It was very quick. So in this case, there's nothing fancy going on. I allocate memory on old memory big list, right? There's no reference, no pointer to anything, no binding. It goes out, right? So importantly, there is no binding to, yeah, yeah. If we had another variable, yeah, so that's another point, right? If we had another variable pointing to it, it would not be garbage collected. You guys are clear on that? Okay, all right. So these are all you don't need anymore. Anything else we did not cover today? Let me take this scoping. Class and instance scoping. Yes. And let's see, binding. So use referencing. So heap. Yeah. Macros you don't need to worry about. Let's see what the official, the previous, like 3 years ago, different. What they talked, you didn't cover maybe something. Binding, functions, entities, variables, static binding, dynamic binding. I think heap, stack, pointers, garbage, right? Dynamic reference, scope. All right. Overloading within so I'll mention overloading, of course. Okay, yeah, oh yeah, Alice in shadowing. We can do that. We have 2 more minutes. Okay, let's do that. Shadowing. Shadowing is the process of what? Yeah. Well, okay. That's the thing. I kind of disagree, right? Personally, I think it has its own place, right? I think it actually makes sense. Sometimes, but so shadowing should be used with care, with caution. I personally really like this idea. Actually, why? Let me talk why I personally like shadowing, right? So let's look at an example, and I'll show you the idea why this is actually, I think, not so bad. So example of shadowing, right? So global, yeah, global var, right? Global var, right? You have global var, right? Right. So this is sort of, yeah, global var, right? And we also have print, no, globals, right? Right. So we can also access global, right? So then use key value, right? So let's take a look at this, right? Let's take a look. So this is sort of bad example. So this is a bad usage, right? So this is a bad, so not so, all right? Not so good shadowing example, right? Not so good shadowing example. All right. So this is sort of like bad usage, right? Why? Because of course we are not really, we really are. There's 2 values, 2 different scopes. I'll show you the usage which I like personally, and I think it's completely normal. Instead, right? A good shadowing, in my opinion, of course, right? Example, we pass in value. Yes, that's what I like, right? So, right, right, right. So, uh, parameter, function parameter, right? Some name, right? Right. Yeah. So, right. And this is completely fine. Right. Technically, technically we are using, it's clear. Okay, so hopefully, right? An author name, right? So some name, right? Like this, right? So yeah, so I'm passing it, right? Let's take a look at this, right? Right. So technically, yeah, right. So here some name is local, right? Right. However, outside it could be a global var. It could be there. There could be some name variable as well, right? So that's completely fine. In my opinion, this is completely fine, right? Of course, the only thing you have to be careful, last thing, of course, with the bow example, right? With aliasing, right? You have to be careful, right? Careful, careful when shadowing mutable objects in Python, right? My list, right? Before, right? No, shadowing list, shadowing mutable, example my list, right? So, as we know already, right? So, my list, right? So, of course, again, right? Again, my list, yeah, just, right? So, we'll have 6, right? And, of course, let's do one more time. Yeah, you don't want to copy. Right, so 666, right? 666, right? However, now, now if we called a function with copy, yeah, so let's do this, right? Yeah, well, I'll just do copy, basically, copy constructor, right? Mm. All right, so inside, right? However, print, right, 666. So let's take a look at this example again. All right, so you see this outside my function list is not affected. So there's 2 different objects basically, right? So if you call the copy, right? Because on this copy, yeah, note this copy, right, is gonna be forever gone, right? Note above copy is going to be gone, destroyed because we are not saving it. Yeah, right? Yeah. All right. So that's of course that's a Python specific thing, right? The bind the shadowing, careful with shadowing. Of course, it's very convenient because it makes sense, right? If you have a comment, you cannot come up. You have something when you are. Maybe let's take away on shadowing, more on shadowing can be convenient if you are referring to same type of same thing in different scopes. Yeah. 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 Foo. Yeah. All right. So that will be it. All right. Any questions on names, bindings, and scopes? So closures. Could you do a closure if you need to? You could. Maybe. If you're not writing Java, so how many people write JavaScript, their jobs or anything? No? A little bit? No JavaScript? A little bit.
TypeScript, not JavaScript.
TypeScript. Yeah. No, okay, that's good. That's good. All right. Okay, so yeah. Otherwise, you'll be okay. All right. So And these, of course, things sometimes again. At least now you'll know if something is not right. You'll sound very smart. And you say, okay, yeah, this is inner scope. Yeah, that's outer scope. Yeah, that's late binding. Okay, that's early binding. Yeah. All right. See some of you guys in a few moments. Some of you I see on Thursday. Thank you, everyone.